Mike on surface mount components.
Okay, if we start off with resistors and capacitors, and I'm talking about just ceramic capacitors here, not electrolytic ones, they come in various sizes that have two sets of numbers together. For example, we can find out 0805, that's how we say it, 0805. And what that means is the distance here is 08 and the distance here is 05. And then that progressively goes down, so we end up with an 0603, 0402, 0201. So the lower the numbers, the smaller the footprint. And 0201 is tiny, very hard to see. 0805 is probably the smallest, well 0603 is probably the smallest you feel comfortable to hand solder. You can do 0402 but you need a microscope. 0201 you definitely need a microscope and it's very annoying. So that's how resistors and ceramics work. When we look at tantalum capacitors, which are the capacitors which are polarized, we find a pen that works. John just sabotaged me there.
It worked fine till you got home.
That doesn't work either. What's this lab turned into? Okay. A polarized capacitors normally got a mark on one side. So how these work is case sizes. You'll have case A, B, C, D, E. And the case size determines the standard length and width of the capacitor. So if I remember right, a case A is the smallest one, and a case D and E is actually quite big. So how would you find out which one that you're going to use? Well, obviously a capacitor has a capacitance, and that capacitance is directly related to the size it is normally. And you link that capacitance with a voltage, and that also is related to the size. So if I had a 1 microfarad 5 volt tantalum capacitor, I could probably get away with a type A, case A or case B. But if I had a 10,000 microfarad 60 volt capacitor, I'm looking at case D or case E. How would I know? I would go to somewhere like Farnell or Mauser, an electronic component supplier, and I would type in the capacitance and the voltage of the capacitor I'm looking for, and I would see what case offerings they're sold in. And they would all use these standard case sizes. They'll say this is available in a case D or a case E. It might be a lot cheaper in a case E because it's bigger, and therefore it's going to take more real estate of your PCB, so therefore they're selling it cheaper. So the smaller you go, typically the more expensive it gets. So tantalums comes as type A to type F for case size, the two numbers for resistors, and then we have ICs or chips, whatever you want to call them, and they will come in all sorts of various sizes. The most common one is what's known as a SOIC 8 or a SOIC 16. And now you have to look these dimensions up. They are standards, but you have to look the dimensions up. So again, you go to an electronic supplier, you find the chip you want to buy, and you see what packages they offer it in. They might offer it in a SOIC 8, they might offer it in a TSOP 8. And the difference is the pitch and the width of this and the length of this. Pitch is very important because if you've got an 8-pin chip and you put that down on the pad, the pitch of those pins, which is the distance between the centre of one to the centre of the other, is very important. So you need to make sure you've got the right pin count. You need to make sure that the package, the width of the package is correct, because a TSOP package will be smaller with tiny legs, so the actual width will be less, the pitch of the pins will be smaller, so you wouldn't be able to solder that package into that footprint, even though the part is exactly the same. So they might offer, the electronic supplier might offer an LM384 as a SOIC 8, as a TSOP 8. They might even offer a QFN. A QFN, for example, has no pins. It's a square and it's got little pads all around it, like this. It's got no legs. They've just got metal pads on the sides. Still perfectly solderable, lovely, tiny real estate, so people like it because they can make smaller circuits. But you need to know. So what you do is you find the IC you want, you go to an electronic component supplier, you see what packages it's available in. And there's all kinds of IC packages. And I think that just leaves electrolytics. And electrolytics works the very same way as the tantalums with the case sizes. But the difference is you'll have footprint that looks more like this. So you have two pads, but it will be polarised on one side, and the SMT capacitor will be sitting on top of that, as you saw on the amplifier circuit. And that comes in a wealth of different options as well. There's also things like transistors that might come in as a 3-pin, like this, look like this. Again, you find a transistor, BC508, you go to the electronic supplier, you see what footprints they offer in, and they'll be standard footprints. So then, even if you get the data sheet for the component you're looking at the back of the data sheet, and it's always at the back, I don't know why, but the last pages of the data sheet will show you all the footprints that that's available in. And it will show you what they call a recommended landing pad. And what that is the data sheet telling you how the manufacturer thinks the very best pad alignment is available for that component.